In this video, we're going to do 3 examples where you are to find f inverse of x. And when the notation is given as it is in these directions, where you see either just the f inverse or the f inverse of x notation, this is function notation. So it's telling you to find a function, and you can't find a function if one does not exist. And so if it doesn't exist, you're going to have to do the domain restrictions. So keep all that in mind as we go through these 3 examples. And we're going to be following the steps that are on page 4 of your study guide, right above where the example started. And these look very much like the steps in the book, with one additional step that I'm introducing to try to help delineate your thinking and make you more inclined to remember the process all the way through when you see it in the future. Alright, so step 1 is to verify that the function, the inverse function, exists by making sure that the function you're given is 1 to 1. And remember, a thing is 1 to 1 if it passes both the vertical and horizontal line tests. Well, this is a line that passes through the y-axis at 5 and has a slope of positive 2. So, and it's a slanted line, so just get this in your head. Any slanted line is 1 to 1. Because no horizontal or vertical line would ever intersect it more than once. So this is 1 to 1. So after you do that, step 2, and step 1 talks about the restrictions, but that's going to take care of itself if you follow my step 2. So the domain and range for the given function, the domain and range of this one are all real numbers, so this one's going to be kind of boring and silly, or feel silly, in that we're going to talk about the domain and range so much. So just remember that when you're dealing with inverses, the domain of the original function is the range of the inverse and vice versa. So for the inverse, the domain and range will be the same as the the original function's domain and range, just because they're all real numbers. But the other 2 examples won't be that way, and it'll help you get your thinking straight about that. So that's steps 1 and 2. So now we're going to step 3, which is to switch x and y. And remember that f of x is y. So I'm going to replace f of x with x. I'm going to replace x with y and solve for y. I'm sorry, I made that 2 negative, and it's not negative. That's 2y plus 5. So I then subtract 5 from both sides. Try that again. Subtract 5 from both sides, and I get 2y equals x minus 5. And then y is x minus 5 divided by 2. So there's my inverse right there. Alright, but then when I write my final answer, I want to switch into inverse function notation to be emphatic that this is, in fact, a function. And I can write it just like I found it, which if I wanted to plug it back in and verify that their inverses by solving for x, it would be easier in this form, but you could also write it as slope-intercept form if you were so inclined, but either one is the same function. So then once you've done this whole process, all of this is really the answer that I'm asking you to find. So anytime you're asked for an inverse, this is what I'd like to see. Then on number 16, we've got a little more work to do here, but we start off making sure this is 1 to 1, and if you need to, you can graph this, but by the end of this chapter, hopefully you won't need to graph this to recognize this as a function that would look just like the inverse function, just kind of slid around the screen a little bit. So this is 1 to 1. Now, if none of that made any sense to you and you're like, what is she talking about? Pause the video, graph this function, and look at it to make sure that you're comfortable with the fact that it passes both the vertical and horizontal line test. And then we want the domain and range for this function. And the domain is all real numbers except the number that makes the denominator 0, which in this case is 2. And the range is all real numbers except the number that makes the horizontal asymptote what it is. And remember, if the top and bottom degrees are matching, then that implies that the horizontal asymptote would be at 1 over 1 equals y, so that's 1. So we're going to have a horizontal asymptote at 1. That's a terrible infinity. See if I can do better. It's a little better. Alright, so then, because that is the domain and range of the original function, then I know that for the inverse, which I'm about to find, I should expect to find a domain that was the range of its partner, its original function, and a range that is the domain of the original function, so I'm going to set that aside now and do the analysis to determine what my inverse looks like and see if it matches with what we predicted. So I'm going to switch the x and y. So I replace f of x with x. I replace the x's with y's. And I will tell you that most pre-cal students have no problem with anything I've said so far, but then when I hand them something like this to solve, they fall apart. You will see one like this on your exam, or not your exam, but your test for this chapter, so you want to make sure that you follow the steps on this process and watch this video, in particular this example, as many times as you need to get the idea here. And I just realized that I did not replace my x, so I'm going to fix that lest I have to make this video over again. Alright, so I want y by itself. I have a y plus 3 on top and a y minus 2 on the bottom. So I'm going to multiply both sides by the denominator so that I can get rid of this rational aspect to this function. And that's my first step. Well, then my next step would be to distribute this x on the right, on the left, and I get xy minus 2x equals y plus 3. The next step is to get your y terms on one side and everybody else on the other. So I'm going to keep the xy here because it has a y in it, and then I'm going to subtract the y over, and then I'm going to bring the 2x over by adding 2x to both sides, and this is what I have so far. And then I need to factor out the y's. So when I factor a y out of the first term, I have x, and a y out of the second term leaves me 1, and then there's 2x plus 3 on the other side. And then I'm going to divide that x minus 1 off of both sides, and that leaves me my inverse function, which I now write in the answer box area. Wow, that was supposed to be an f, and it kind of stopped on me. F inverse of x equals 2x plus 3 over x minus 1. And now I want you to compare this to the predicted domain and range. And these should all fit, because the domain of what we just found would be everything except 1, which we had predicted from our original analysis. And then the range would be everything except where we have the horizontal asymptote, and with the matching degree, that would happen at 2 over 1. So that matches, so that verifies what we did. And that's the way math works. When you do it right, all the pieces should match up and fit together. One last example. And I will tell you, this one is easier in terms of the analysis, but it takes a little extra work on the back end. So we're going to go an extra step with this one, just so you can see how all this works. Again, you need to verify that this is 1-to-1, and if you don't know what a square root graph looks like yet, which you should, but if you don't, stop and graph this function and look at it, again, to make peace in your own mind that this graph would pass both the vertical and horizontal line tests. And the fact that the authors are expecting you to be at that stage where you don't need the picture is the fact that these are gray bubble problems, but I'd rather you look at the graph and see what you need to see so that you're not panicking and doubting and stressing over the fact that you just had to take my word for it. So pause the video and graph it if you need to. Alright, then we need our domain and range, and the domain of this function is based on the fact that there's a square root involved. So what's under the denominator has to be greater than or equal to 0, and the only way that can happen is if no number smaller than -2 is in the domain, because -2 makes it 0, and then I could have any number bigger than that and I'd be okay. So my domain is -2 to infinity. If you still need to set x plus 2 equal to 0 and solve, that's fine, but just remember, or not equal to 0, but greater than or equal to 0 for this case. Then that's my domain, And my range is going to be from whatever the y coordinate is at the point from where it starts, which is 0 to infinity. And again, pause if you need to see that domain and range in the graph by graphing it, even if you didn't graph it the first time I mentioned it. All right, and then once we've done this, we're going to use our domain and range to predict the domain and range of our inverse. So the domain and range for the inverse should be the reverse of what we just found. Let me see if I can make that brace look more like a brace and less like a mess. So the domain of this one is the range of what we started with, so that should be 0 to infinity. And the range of this one is the domain of the original, which should be -2 to infinity. Now we do the analysis to come up with the equation that matches that domain and range that we just realized we're working from. And so we copy the equation, replacing f of x with x and the x's with y's. And in this case, there's only one y. So then we work outside in. So the first thing would be to square both sides. So we have x squared equals y plus 2. And then we need to subtract 2 from both sides. So we get x squared minus 2 equals y. And once we get y isolated, that is our inverse. So we come over here and say f inverse of x equals x squared minus 2. And this is where you probably need to pause and think about this, okay? After you hear me out, of course. All right, we just found an inverse that is x squared minus 2, which in our minds is an entire parabola. But because we wanted to define an inverse function that is one-to-one with our domain, with our original function, we have to abide by the domain and range of this restriction that came from the original problem. So the way we do that is to define, even though this isn't, the inverse that we found is actually a whole parabola, we're going to eliminate the left half of it so that it would actually reflect and be the inverse of what we were given. So let me show you on the graph what I'm talking about, because this one's important enough that I actually graphed it and included it in the video, and here it is. All right. Now, as you see in this picture, as I said, if we just leave x squared minus 2 as our inverse, then what we get is what you see here. And we don't want all of that, because we only want the right side of it, because that would be the reflection of the blue graph, which is our original function, the square root graph. So I'm going to do what I did earlier and eliminate the part I don't want to see, and this was on an earlier video, but I'm going to just kind of color over all this side that I don't want to be there. And then I'll try to remember to make a video on how you can make your calculator just show you this part. It would actually not even graph what I'm eliminating. So now when you look at it, you can see the reflection in it. Now, if you feel like it's a little bit lopsided, it is, but it's because our window is rectangular and not square. If we could get a square view, we would see the symmetry there better. But remember, when you have two inverses, they should reflect across the line y equals x, which should look like that, and go back out the other side like that. And so then you can see that what we have is correct. And this matches the restriction that we brought in for the domain of our inverse. And let me do this, in fact, let me do it in red. That way it'll actually color code to everything I've got here. So the domain of my inverse then is going to be 0 to infinity. And my range is going to be -2 to infinity. So that matches everything that the analysis and the steps that I have in the packet told you to expect. And that's the end of this video.